Hey there, and welcome. Today, we're going to dive into a topic that for a lot of people feels like one of algebra's most random, confusing rules, completing the square.
And come on, let's be real. You've probably asked yourself this exact question. I mean, if you can already factor things and you've got the quadratic formula memorized, why in the world do you need another way to solve these equations? It feels totally pointless, kind of like a magic trick with no explanation. But today we're going to pull back that curtain and show you why it's not magic at all. It's actually one of the most powerful and, believe it or not, intuitive tools you can have.
So, first things first, let's look at what usually causes all the headache, the standard, step-by-step recipe that you're just told to memorize in class. Yeah, you know the drill. You're given this 5-step process. Okay, first, move the number without a variable over to the other side. Fine. Then, make sure the x squared term has a 1 in front of it. Got it. Then, you're told to take half the middle number, square it, and add this magic number to both sides. Then you factor, and somehow, it just magically becomes a perfect square, and you solve from there. It works, for sure, but it leaves you with a huge question.
Right? I mean, why on earth is that its name? It seems so specific. Well, it turns out the name itself is the key. It's a huge hint that there's something much more visual and intuitive going on here than just a dry algebraic recipe.
So let's actually look at the picture behind the name. This whole idea isn't new. It goes way, way back to the 9th century and a mathematician named Al-Khwarizmi, and he had this brilliant way of thinking about these expressions not just as symbols on a page, but as actual physical geometric areas.
So here's the big idea Al-Khwarizmi had. Visualize the pieces. The term x squared is, well, literally a square with sides of length x. And the term bx, you can picture that as a rectangle with a side of b and a side of x. Simple enough, right?
Now here comes the really clever part. We take that bx rectangle and we slice it right down the middle, creating two perfectly identical smaller rectangles. Each one of those new pieces now has dimensions of b over 2 by x. Now, algebraically, what did we just do? We took half of the coefficient of x. Sound familiar? It should.
Okay, now let's just rearrange our shapes. We take our main x squared square, and we place those two skinny rectangles on two of its sides. And look at that. We get this L shape, which is so close to being a new, bigger square. It's almost there. You can see it, can't you? Right there in the corner. There's a little empty spot. There's a piece missing. So, what is it? What do we need to, literally, complete the square? And boom, there it is. The missing piece is a tiny little square. And what are its dimensions? Well, its sides are b over 2 by b over 2, which means its area is b over 2 squared. That is the so-called magic number from that recipe. See? That step was never magic. Adding b over 2 squared to both sides is the literal geometric act of putting that missing piece in to finish the shape.
Okay, so this is way more than just a neat historical trick for solving one type of equation. This skill of being able to shapeshift an expression is unbelievably useful all over the place in mathematics.
For example, it's the bridge that gets you from the standard form of a parabola to what we call vertex form. And why do we care? Because vertex form, y equals a of x minus h squared plus k, is awesome. It just hands you the parabola's turning point, the vertex, on a silver platter. It's the point h comma k. No guesswork needed. Completing the square is how you make that conversion, which makes graphing parabolas an absolute breeze.
And it's not just for parabolas, oh no. This exact same technique is the key to unlocking all the conic sections. You can take a big, messy general equation and use completing the square to whip it into the standard form of a circle. And once you do that, you instantly know the circle's center and its radius. It's the same idea for ellipses and hyperbolas too.
But hang on, there's one more secret, kind of the ultimate payoff for really getting this concept. You could even call it the origin story of the final boss of every algebra class.
Just think about this for a second. What do you think would happen if you took the most generic, universal quadratic equation you can write, ax squared plus bx plus c equals 0, and just went through the steps? What would you get at the end?
Well, the answer is kinda mind-blowing. This quote says it all. The quadratic formula is attained by taking an arbitrary quadratic equation and completing the square. It's not a different thing, it's not another option, it's the exact same process.
That's right. The big, famous, all-powerful quadratic formula, it isn't some rule that was just discovered. It is what you get when you complete the square on the general form of the equation. It's the prepackaged result solved for x that works for every single quadratic you can imagine. It's not a replacement for completing the square, it is completing the square. All right, so as you go and use this amazing technique, let me just give you a heads up on a few common tripwires. First, always make that x squared coefficient a 1 before you do anything else. Second, when you add your magic number, you absolutely have to add it to both sides to keep your equation balanced. And a sneaky one, if you factored a number out, remember to multiply by that factor when you add the number to the other side. Just avoiding these simple slips will make your life so much easier.
So I'll leave you with this question. Now that you've actually seen the geometry, the picture behind the algebra, what do you think? Is completing the square just some random procedure you have to memorize for a test? Or is it a really cool visual idea that you can actually understand? Because when you see the why, it doesn't just make the how easier to remember. It starts to change math from just a list of rules into a whole world of connected, visual, and honestly, beautiful ideas.